Testing, 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 testing. Okay. One. Okay. Valid. Parenthesis. Okay, let me move stuff over here. All right. Given strings, it determine as is valid. Open must close. Okay. So each of these must match, right? So look like every time we see like a close one, it must match the corresponding one, right? And that means we need to store the open, right? So okay, so stack for parenthesis in S, right? If P equal so we should write a function is open, right? Given a characters, return C equal what? This one, or C equal this one, or C equal, oh, got to post the link here. Valid parentheses, link to the code to the program. Alright, so this one as well. Right, so if it is open parenthesis, then we put them in the stack. Right. So let's actually do a DQ, right? My favorite now. Okay. Right. So this would be Python DQ. DQ. This one. You can do the pen. A pen, yeah. Right. Otherwise, if it is closed, right? So if it's closed and not match, right? With the last one, right? If it is closed and not met, and okay, we have to also pop, right? So if this is not a function, one, this one, right? Okay, so now it's close. It's much met whatever on the stack, right? Okay. If it's not match, if it's match, we need to pop, right? If not match first, right? Then with stack, can we pick on the front? We can actually pop, right? Stack dot pop right, right? Is there a pop right? Yeah, pop. Okay. And return false. Otherwise we continue. We get to the end. True, right? So now let's write the function match. Okay. So which is E B. Right, so open and close, right? With match if O equal this and C equal that, and it's match, right? Done. So actually it can only be true if O equal this, C equal that, right? Or so we can just do is match is valid, right? Parent, right? Open and close. Whatever, let's just write a 3 if here, right? So or right? So was this one, finally this one, right? So let's run this. Oh, equal. Okay, so that should be it, I think. Submit. Oh, so we also have to do the same thing here, right? So out here we gotta say return. How do you get the stack length? Python stack length deque length. Is that such a thing? Yes. Length, right? Return, basically. Can we just do return stack, right? Does that imply boolean? So basically this has to be empty. submit. Hope it's closed. Okay, so the situation is if the stack is empty, it's also wrong, right? If length of stack or right? Okay, submitting. Right? How do you get this high? 0%. Oh, maybe, okay, maybe there's a solution to just not allocate, right? Is there a solution to not allocate memory? And just use the input as the memory, right? Right. Okay, fine. Go to the next one. This is the second problem. You're given a string S. Integer k. Instead of choosing k adjacent, an equal letter from S. Remove them, causing the left and right side of the deleting to concatenate together. We repeatedly make k duplicate removal on S. K isn't, does that mean it's consecutive? You will no longer can. So k equals 3. We need to choose k duplicate. A k duplicate removal consists of choosing k adjacent, an equal letter from S. So we need to remove 3 letters. First delete EEE and CCC to get this. Right. So while we need to assemble, right, the range, right? First we count the number of duplicate. If we found like what? If we count a group of letters, right, that is equal to what? Equal to 3. We keep removing that until we go to 3, right? And we do the same. And at the end of each, if we couldn't find any duplicate, right, we're done, right? There's nothing to delete. Okay, so if we found a duplicate, we we put the position, right, in. So let's say if it is 6, right, as long as it is the multiple of this, consecutively, right? Or we can store the index from 0 to whatever, right? Let's just do that. Okay. So we need to have a way to store index to index so that we can do a string split stuff, right? So like we can clearly count the consecutive, right? So and we probably have to have a buffer here, right? Let's call that buffer, right? So while s, right? And so after these, hopefully s equal buffer, right? So condition here that we need to find group of consecutive Crimson Desert is out. C, that is the multiple of k, right? Right, so maybe we don't need buffer, right? Okay. So for example, like this, we found these to these, right? So if it's that, then we skip them, become dd. Okay, let's see if we them correctly. This one, right? So first we want to found EEE, right? We skip over that and DDB, right? B and then DD, this one, right? So when we skip over that, is it easier to start from the beginning or we can just go from there, right? Right, so now maybe just go from there, right? CCC is gone. We would get this and this, right? And we do from beginning again. We found BBB is gone. Now we found this, right? When we found this, we can only found right, we can do, or we can just do put the index in, right, and then we loop through the index and do that, remove, right? Or is there a better way? Or maybe we can do is we build, let's see, we can look at the frequency and see. Okay, we got D here is 0, right? We got the frequency from here to here, right? And if each letter is greater equal to 3, right, then E here is chunk from this, and C here is chunk from this. So the goal is to delete those, right? So we got the frequency. So let's say D is from this to this, E is this, right? So any position that is nah, the frequency one just too cumbersome, no? Alright, let's just do with this approach, right? So if we found a 3 number, then we keep deleting, and then the ending conclusion is when, like, say for example this, if we can only count or like and so maybe we add a buffer for the group of those and we keep deleting them, right? So let's do that. Okay, group equal that, right? So in this case we have 0, 1, 2, 3, right? So we will store index of the group of 3, right? So here is also as well, right? And at the end we would have to what do we call this? Skip over K group 1 can, right? So I guess if we couldn't find anything, then we just return S. We just break. Right, so Y true. Return S, right? Okay. So now we need to find this group, right? So we need to have some kind of count, right? Count. Right. Okay. So we got a loop, right? While got a loop. First we gotta find, right? We gotta find E, C, right? Right. So first we gotta do yi is less than and of s plus equal 1, right? So if count plus equal 1, right? if not, right? If there's something, if, so we need to have a way to so if the so in fact we can just like we get this, okay, that's the first one, and we get this, we look on the left, right? So that means, do we even need the count, right? So if si I is greater than 0 and si equal si minus 1, right? Then count plus equal 1, right? Right, so we look at this, we want to make count equal, so start at 1, right? Si equal, then oh yeah, count plus 1, not equal, right? Then count gonna reset, right? And basically, okay, so we got this, okay, we look at this, is this 2 letter equal? No. Then count gonna be 1, right? And then we look at this and we say, okay, this 2 is equal, count plus 1, we look at this, okay, this 2 is equal, then okay, hold on, count equal 1, yeah, okay, this is 2, this is 3, and if it's not equal, then we do that, right? So then we check if count is equal to okay, right? Then that is, we found the first group, right? Then basically we do okay, groups append, right? So there's gonna be a tuple of current position is so this just means that this is not equal, so it's gonna append I minus 1 to I minus 1 minus k, right? So like what? 0, 1, 2. So it's gonna start from this one. No. So 0, 1, 2, 3, right? So it's gonna be 3 minus k. 3 minus k is plus 1, right? So okay, 0, 1, 2, 3, 4, right? So 4 minus 3 is 1. So 4 here is I minus k. Yeah. So basically it's gonna be I minus k to I minus 1. Right? So if not, then we done. Okay, if there's the group, if there's not a group, then we done. Otherwise we build a new S, right? SS equal this, and then S equal SS, right? So YK groups is gonna be from beginning. Okay, so hold on. Be from to inclusive, right? Okay, group dot pop, right? Pop 0. I think Python list pop, right? Does it do default or pop the front or the back? Last item, so pop 0, right? And it's gonna be plus equal. So now we have the from to, right? So we're gonna skip over these. That means right. We skip over that. That means okay, 0, 1, 2. So okay, so this is we got 1 to 4, 0, 1, 2, 3, 3. Right. The other one is 0, 1, 2, 3, right? 4, 5, 6, 7, 8, 9. So 7 to 9. Right? So basically it's gonna be, you want to skip over these, right? So if we look at this, then it's gonna be from the beginning to F, right? Plus, is it from the right? So the beginning to the end. Or in other words, can we know from here that we can do 0 to 0? Oh no, but we don't know the front, right? So we still have to figure that out, right? So we still have to okay, so basically start will be from the beginning to okay, so we need to do ft equal k group dot pop, right? So we starting at from the beginning to F, right? Right, so if we in this, the next one gonna be this plus 1 to that, right? So first when we got this mean, so we got the beginning to F, to not including F, right? So which is this, right? And then from if we found another one before we do that, it's gonna be from here to here, right? Gonna be, so this is, do we need an OT, previous T, right? So this give you 7 9. So every element after this, right, we can only get from this to that, right? So plus equal, so let's do previous F, previous T, and the current F, T, right? So first here we're gonna be F, right? So this is, what is it? Okay, so we still need that. So this gonna be from the previous n plus 1 to not including in this, right? Right, we go. So then we do that, then 3f pt equal ft, right? So first we start from the beginning to not including this, right? So 0 to 0, right? So that, and then we pop again, we got, right, we got 4 to 6, right? 4 to 6, so that means 4 to 6, right? And then after that we done, then we gotta do 10 to whatever the end, right? So we out here gonna be what, 50 plus 1 to the end, right? Right, and then we replace s with ss. Well, let's see, this is correct. Oh, so it's gonna be this. Okay. Do we infinite loop somewhere? Yeah, we infinite loop somewhere. Okay. So the condition really is, right, so let's put a count debug here. Right, let's say we got what, 1 2 0 1 2 3, right? So 4, right? And debug is less than 5. We do this, debug plus 1. So out here we print the K group, see if it's correct, right? And then we out here, then we can just print the current s, right? And then different, right? So we have what? 1, 2, 3. Good. This is 7, 9, yeah. And this one we got 0, 1, 2, 3, 4, 5. 3 to 5. Right. And whoa, what happened here? Right. So what do we have? 3, 5. Do we have 3, 5? So something happening here. Right. 1, 3, 7, 9. That's good. Then this become this. Start at 1. It's less than that. But so we ask, okay, it is equal, okay, 2. Right. So the count here has to be reset, right? Right. So 0, 1, 2, 3, 4, right? So that it become, what does it expect? AA. D, 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 AA. Good. Why does it not found the thing, right? So first, this is original string, become this. With this, it become that. And the K group here is wrong. So that of 1 here, let's see. What's wrong here? Print come. Is 0, 1, 2, yeah? It can equal K. Does count start? Oh, count should start at 1. Right. Because we count the first one and we look. Right. How about that? Okay. So that is fixed. What's wrong with this? K equal 2. Something is wrong here. So 1 to 2. Okay, 1, 2. So let's not print all this because it's too much to work. Let's do that. What's wrong here? 1, 2, 3, 4, 5. Good. Okay, something is odd here. So BB is gone, GG is gone. So BCC, TT is gone, II is gone. Okay, so let's look at this case. So we want to do something wrong with the loop. Right, so BB gone, GG gone, TT gone, II gone. PP gone, OO gone, AA gone. So BCCIIS. And here we have wrong, right? So the thing here is probably wrong, right? So we could print the SS here. Building SS. Right. Finally print SS. Right. So this is out. So what's wrong with this case? So we got B, C, C, I. Okay, so something is wrong here with. So the first one will be CII. Okay, B, C, C, I. So K equal 2. We count wrong. So we got 0, 1, 2, 4, 5, 6, 7, 8, 9, 10. Okay, so something is odd here. So if this is not equal, then count equal 1, right? So this is correct. Okay. 4, 5, good. 6, 7, still good. Then we add here. We ask, okay, this is not equal, then count equal 1. And we said, okay, this is not equal, then count equal 1. Then these two, these two, these two. Something is wrong here, guys. So 0, 1, 2, 3, 4, 5, 7, 8, 9, 9, 10. We don't see 9, 10. 11, 9, 10, 11, 12, 13. Okay, 12, 13 is here. Right? Okay. What's wrong here? So if the current characters below to this, the current character we started this, the current character is equal to that, right? Then we increase the count, right? So if this is equal, no. Then if it's not equal, then count equal 1, right? Because we start shipping to this. Okay, this is equal, good. Then this is 2, right? Okay, and then we look at this. Okay, this is not equal, and this we set back to 1, right? And we look this. So it for some reason it up until here, 6, 7. It doesn't put 10 and 11 at all, right? So let's see. Count SI S I minus 1. We put si equal si minus 1. Right? So 1, B and P no, good. So then we got count plus 1 as not equal, then we measure the O count. So we got count equal K, right? Count equal K, then we have we will have this to this, right? Let's see some debug. BB good, and then 2, okay, and we put that. So right now we need to print the index. So if the current character is not equal to that, yeah, it should be it, right? Why? So 1901. What? 67, right? So right now 0, 1, 2, 3. Why is I 1 here? Okay, hold on. What did we do? Oh, that's the count. Sorry. So the I here is this one. So count now equal to 1. Right? We look at I and C. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Okay, these two are not equal. Good. Right? 9 is this one. So if we look 10 and 11. 10 and 11. 10, okay, good. Yeah, so then K equal 2 here. And oh, so if count is starting at 1, so if this not equal to that 1, and then we another one count equal 2, right? So basically if it's not equal, then we check. So oh, but if it equal here, and we also have to do this thing, right? So this is the missing part. Right, we need to do is right here. So the count to that, then count gonna be, so we look at this is not equal, okay, this and this is equal, okay, so that is we increase, right, so start at 1 and we increase that, okay, if it is that, then equal to 1, right, if it's not equal we also reset, right, maybe what, okay, so let's see if we can fix the issue here. Okay, so now we have off by 1 now. If count equal to k, 0 to 1. Okay, so somehow we off by 1 here, right? Hold on. See this. Count equal k true. What? Okay, so we want to look at 9 one, okay? Okay. If this is not equal, I feel like we can check the count here, right? Outside. Right? So it is not, if somehow after this thing make the count become the value, right? Okay, hold on. So if we are this, okay, they're not equal. If they equal, we increase the count, right? If the number that we increase is actually after this condition, then we need to measure that the group, then count gonna be 1, right? So if it's not equal, then there's no increase in count, and we just need to do this, I think. Right, so what's wrong with this? Calculate k, choose 0 2, okay, 0 what? So we count D, okay. If they not equal, we also need to, if they're not equal, we need to reset, right? But we want to do the check here, right? So we found the count, okay. So if they're not equal, then count gonna reset to 1. But before we reset, right, we have to check, okay. We have to check, okay, if the count is actually k, right? So basically, okay, so we want to do this check, here, right? Regardless. Okay, so let's put a previous count here. PC equal count, right? If the previous count is k, right, then because count equal 1. Okay, so if we found, okay, so previous count is equal to count here. Okay, so previous count is equal to count. So count plus them. Alright, so if it is equal, if they are equal, then we want to, it's just the same complex. I don't want to keep track of the previous. So if it is that, then we want to say, okay, if the count is actually that, then we do that. Okay, then count gonna be back to 1, right? Otherwise it's not equal, and this is also that, right? If the character now is not equal, right? So regardless of this, we need to check the thing first, right? So what we can do is, maybe we do this, right? Then we ask if the current one is not equal to -1, we also reset 1, right? But what? Count equal k. True. Okay, so first we do is not equal. Then basically after all this, we want to know what is the count. Count start at 1, and at index 1, E and D. Okay, they're not equal. Good. If they're not equal, then count is set back to 1. Good. And 2 is okay. If they are equal, count equal to 2. So yeah, count equal k. No. Then yes. So true. Okay, it's equal that. So we found 3 letter now. So 0, 1. So I 0, 1, 2, 3, right? 3 minus k should be 1, right? So I minus k is count equal to k. Then 0, 1, 2. So 2 minus 3. Right, so it's gonna be 0, 1, 2. Minus 1, right? From that. So 0, 1, 2, 3. So I here is 3. 3 minus 3 plus 1. Right? that to the current I, right? Okay, something's still wrong. So we had 1 to 3, 7 to 9. Do we have that? 7, 9, yeah. So out of here, we print the group. Okay, groups. Bruh, all of this take a lot of time, bro. Debug. What? String object? No. What? This is comma, right? Okay, so whatever. What do we have? What group we have? Somehow it's 09. Count K, right? Ben. True. Oh! There's one guy. And we forgot to fix this. So let's just take off this. See what our group look like. What? Okay, that's good. So now what happened here? 0, 1, 2. Right, okay, good. 3, 4, 5, 6, 7, 6, 7, 8, 9, 10. Oh, 10, 11. Something is wrong here. Right. So we got almost there. We have one character left, right? Somehow. So, okay. If they are equal, increase by 1. If the number you increase, make it become that. Okay, so what happened here? So I think this building SS probably correct. Right. So we have off by 1 for some reason. Right. So now somehow we got 0, 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 9, 10 here is in here. And then we have this. We add these. If this is equal, it is equal. So then count reset to 1, right? If it is equal. That's right. Right. So count equal 1. So let's look at these stuff and see why do we not have that. So the one we need to watch out is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So starting at 9 is something funky happening. Right, so 9. Okay, so we had this is not equal, then count equal 1, right? So now we're at 10 and 9 equal, good. Then we add that, so 9 to 10, right? So count is back to 1. We got, oh, did we set count to 0 though? Now count should start at 1, right? So these two equal. So this one is back to one, these two back to one, right? So that is I see. I see here. To make it false, then it back to one, right? So which is one here. So 10 is I. Okay, good. That is one here, right? We add them, right? And now we have these two. Okay, these two is the same, right? So we had some failure here. What is it? My friend sent the cat. Some cat videos. Cat is running away. Okay. So if this is not equal, then count one. Okay. If this is equal, then count one plus one. That's two. Right? So if count equal k, then okay, maybe this is 0. Yeah. Oh my god. Took too long to develop. Need to get better at string parsing and handling. But let's see if this passes first. Oh, wrong answer. Okay, good too. Oh, they expect nothing. So something we did is wrong. This is the last test case. So they're expecting empty and we got everything. So something that we did is kind of wrong. Right, so let's debug this. Okay, so what do we have here? Right, out. Okay, so we got these last two is the same somehow. So that means we got from the beginning to this, and we outside just print the length of the S here. What? Okay. Oh, sorry. Would be this. somehow we found the same. Let's look at S from if tons of debugs, guys. If length S equal to this, then we can debug, right? We can print this. So this is from this to this 9, right? What is this characters? Why is it the same? ZZ, right? And K equal 2. What? Did I understand the problem statement wrong? What is going on here? I want to know where's ZZ, guys. So let's look at somehow the ZZ is gonna be deleted, right? The expected empty string. Oh, okay. So maybe all of these is matching, right? So this one right here, right? So what we did is these two match, so we might have understand the problem wrong, right? So choose given string teach k, choosing k adjacent and equal letter from S. Okay, ZZ, right? So okay, so maybe after we delete ZZ, what the hell is wrong here, guys? You're going straight as causing the left and right side of the deleted substring to concatenate together. Okay, right? So if we found ZZ, right? Somehow after deleting ZZ, okay, group. Okay, so let's do this. Something is wrong. Right, so oh guys, maybe it's oh god damn it, and it's past 21k. Holy shit. Okay, does this time limit exceeded or no? Judging. Okay, time limit exceeded for sure. Some big case happening. Or maybe this while loop is not necessarily. So basically what happened here is the moment we keep deleting these, right, if we do like this, we eventually delete the entire string, right? Hey, what if we change this K group to DQ? Then just a pen off left. So how about that? Does it let me pass? Take one argument. Oh. Right. Time limit exceeded. Okay, what if I roll this stuff out? Then do this. Will it pass, or we need to try an entirely different approach? Right? Yeah, for sure. We'll look at this 10 or 15 minutes and we'll probably stop for tonight. Have to play games, guys. Okay, duplicate remove from S until we no longer can. So basically what happened is, I think, it has something that eventually will just make it remove everything. Right? But yeah. Or the fact that we add them to the group is unnecessarily. Right? Because later on, do these processing, it's just too much. Right? I think we'll continue this tomorrow. But yeah, enough